In this video, we're going to take a look at going backwards and given a graph or given information about a graph, how we can write a sine or a cosine equation. All right, so our first thing that we want to do is figure out our vertical shift. The vertical shift, the best way to do that, if you take a maximum point and a minimum point and count your distance. So if we count our distance between that max and min point, we get a distance of 10. We'll cut that in half to get a distance of 5. So you can either count from the maximum or from the minimum. 5 up or down, 1, 2, 3, 4, 5. And that's where we're going to put our middle line. Best thing to do here is use a ruler and go straight across. I probably should have used a ruler. I'm going to try that one more time. So you want the points to match up nicely. I'm going to erase some of the extra stuff that's going on here. All right, now our vertical shift line is going to be at -3. You could also say down 3, but we're going to put it in as -3 in the equation. And then the amplitude was that half distance that we counted. So that distance of 5 here from the midline up to either the maximum or the minimum point. And then we want to figure out our period. So I think it's the best if you take a point starting on the graph, getting a positive sine curve, because the sine curve is very easy to see, like the starting and ending point of the one cycle. And if we look at, now we're going to need to look at our x scale is going by pi over 6. So this would be pi over 6. 2 pi over 6. Well, you could simplify that and then let's get rid of this. Negative pi over 6, negative 2 pi over 6. So if I want to count the distance in between those 2 points here, it's 4 pi over 6. That's going to give us our period. And that simplifies into 2 pi over 3. So this is a really nice scenario because now that I have my period, I set it equal to my period formula of 2 pi over b. Sometimes you'll have to cross multiply. In this case, I think it's really easy to see that our b value is equal to 3. Now, all of this information will be the same for your sine and your cosine curves. What's going to change will be your starting point of your cycle or your c value for each. So what I'm going to do now is I'm going to fill in all this information into each of the equations. So everything is going to be y equals. Don't forget to put that. Otherwise, you have an expression rather than an equation. And then I'm going to put in our a value is 5 for all of them. I'll do positive 5. -5, positive, negative, because I'm asking for a positive versus a negative sine or cosine graph in each. And then our b value we came up with is 3, so we'll plug that in for all of them as well. And then at this point, I'm going to open up a nice big parentheses for each of them and put x inside. And then we're going to be looking at the horizontal shift. So I might not need a horizontal shift, but I'm going to use a bigger parentheses. And then if we really didn't need it, I can always revise that a little bit later on. And then our vertical shift is our last thing. So we're going to put -3 with all of them. Notice those 3 numbers are the same for all of the equations. So now all we have to do is figure out our different c values. I'm going to clean this up a little bit. Go back and put on that shift line. Okay, so I'm going to do this in red. We already looked at a positive sine cycle. That was where we did our starting and stopping point here. Now, technically, I could use either of those as my starting point, but I'm going to go with the first one because I can see the full cycle. And that's really negative pi over 3. So remember when you plug that in, you'll put plus pi over 3 because we're putting in the opposite sign. Now, if I then wanted to do a negative sine curve, I'm now going to look for where the graph is going down first. So I actually could go right here, because if I pick that point on the axis, right after that, the graph is going down. So I don't really need anything here. I could put like a -0, but you don't need that. And you would actually simplify that to just be x. So I'm going to get rid of it. If you want to condense that down and slide everything over, you can. But that won't have any phase shift because it's starting right on the axis. And then the cosine ones are a little bit trickier, not terribly, but a little bit. So for cosine, we're looking at either above or below. So I'm going to pick a point above. And if I look at that, if I were to trace that, I get my facing up view or my positive cosine cycle. And again, I could pick either one of the points. I'm going to go with the first one where I see that full cycle. So I would put in plus pi/6. Because it's at negative pi/6. And then if I want a negative, I'm looking for the graph down below. So I could pick down here. You could also pick down here, either one. I'm going to go with this one. But you're looking for the minimum point underneath your vertical shift. So I'm going to put in minus pi/6 for that phase shift. So the bulk of the information is that beginning information will be the same for every single graph, and then you're going to look for each of the specific phase shifts, whether you're looking at a positive or negative cosine. All right, so let's look at another example. All right, so for this, we're going to go the same route. We're going to look at our midline. So if I count my distance from the bottom to the top, I get a distance of 4. I'm going to cut that in half and get 2. So that process is going to give me my A value is 2 from cutting it in half, and then my D value for my vertical shift is 1. And then we have to figure out our period. So again, looking for one full cycle, I'm going to go with the negative sine curve here and count out my distance. We're going by pi/4. So when you're counting that distance and then putting it over 4. So the distance from the beginning to the end here, if you count it, is 16. It'll be 16 pi/4, which simplifies into 4 pi. Now, when we set this equal, I'm going to make this 4 pi/1 is equal to 2 pi/b. In this situation, we'll have to cross multiply. So we'll get 4 pi b is equal to 2 pi. Divide out the 4 pi, and you're going to get a b value of 1/2. So now I have all the information except for my phase shifts that I can plug in. And then again, we're just going to alternate positive, negative, positive, negative. First two are sine, the last two are cosine. And then we'll put in 1/2. So everything in blue that I'm putting in here repeats for every single function. Give myself some space to put in the phase shifts. It doesn't look like any of them will be at 0 this time, so I will need the space on all of them. And then our vertical shift was +1, so I'll put +1 on each of these. And then we'll go through the same process again to figure out our different phase shifts. I actually already have a negative cosine trace, so if I count my distance to the left, 1, 2, 3, 4, 5, 6 pi/4, that would simplify into 3 pi/2. So since we're going left, we want to put +3 pi/2 in here. And there's different options for this. So you might not have the exact same equations when you go to check answer keys, but your key is to look and make sure that your A, B, and D values are the same, and then make sure that your phase shift makes sense for the graph. And then if I want to do a positive sine graph, I want to start here and go up. So that's just going over 2 pi/4 to the right. which would simplify to pi over 2. And because we're going to the right, we want to put minus pi over 2. And then our last, we're looking for a positive cosine. Now we have a couple different options here. I could do this one, I can do this one. It really doesn't matter. I'm going to do the one that involves less counting. 1, 2, 3, 4, 5, 6. So 6 pi over 4, but to the right. So we're going to put minus 3 pi over 2. And then for the negative, we want to pick something underneath. So I see a nice one down here. And that is negative 2 pi over 4, or left 2 pi over 4. So I'm going to put plus pi over 2. So just make sure those inside ones are also simplified. Okay, so that wraps up the writing equations from the graphs. In our second video, we'll look at writing equations from given information about the graph.